Hey students, this is your hints video for lesson 4.7, which is writing equations in point slope form. So remember that our general equation for point slope form is y minus y1 equals m times x minus x1, where x1, y1 is a given point, in this case, -2, 0, and m is the slope, in this case, 1/2. So we're going to substitute what we know, y minus 0 equals 1/2 times x minus -2. Now, generally speaking, we could simplify that last part of the equation to x plus 2, but it looks like how they want us to write it here in Big Ideas is to leave it as x minus -2. Now, we have several problems where you're asked to write an equation in slope-intercept form, given either 2 points or a point and a slope. So what we're going to do is start by writing an equation in point-slope form, and then we'll simplify that into slope-intercept form. So for this problem, number 13, we're going to first figure out what the slope is because we weren't told the slope. So the slope will be 6 minus 4, that's our two y values, over 3 minus 2. That's 2 over 1, or 2. So our slope is 2. And then we can use either one of these points to write an equation in point-slope form. I'm going to use the first point. So I have y minus 4 equals 2 times x minus 2. Now, either of those points that you choose, your equation in point-slope form might look different, but when you put it into slope-intercept form, it'll be the same either way. So to take this equation and put it in slope-intercept form, I'm going to simplify by distributing the 2. So I have y minus 4 equals 2x minus 4. Then I'm going to add 4 to both sides, and I get y equals 2x. All right, this next one's a little bit tricky because we're talking about temperature and volume, and we kind of have to figure out which one is on the x-axis and which one's on the y-axis so that we know when we're talking about 0 degrees Celsius and 22 liters, which of those is an x-coordinate and which one is a y-coordinate. So we can see here what looks like a slope, the slope of 2 over 25. And what it says is that the volume increases by 2 over 25. So 2 over 25 liters for every 1 degree Celsius. So we could rewrite that and say, well, that's 2 liters for every 25 degrees Celsius. So that kind of helps us see that when we're talking about liters, that's our x-coordinate, or sorry, that's our y-coordinate because that's on top. And when we're talking about degrees Celsius, that's our x-coordinate because it's on the bottom when we're doing the slope, because we know that's always change in y over change in x. So when we're doing our y minus y1 equals m times x minus x1, what we're really talking about here is our liters, or volume minus V1 equals our slope times temperature minus T1. So our V1, our volume that we're given, is 22 liters, so that's V minus 22 equals our slope, which is 2 over 25, times T minus our given temperature, which is 0. And then what we're asked for is to just take that equation and solve it for V, which I think you can do from there. All right, for this next problem, we're given that the value of the car, of a new car, decreases $4,000 every year. So it decreases. So this is telling us that our slope is negative 4,000. It's going down 4,000 every time the year changes by 1. And then we're given a point. After 3 years, the car is worth $18,000. So that's a point, 18,000. So we can use that to write our equation. Now keep in mind that the value in dollars is really the y-axis here. So when you're solving your equation for y, you're really solving for value. So it says v equals, but you can kind of think of that as y equals. And then the second part of this, once you have your equation written, is you're going to find out what was the original value of the car. So you're going to say when x equals 0, what does y equal, or what does v equal in this case? All right, so in this next problem, we're talking about Dolbear's law, where you can predict the temperature in Fahrenheit by counting the number of chirps made by a snowy tree cricket in a minute. Every time the temperature rises by 1/4 degree Fahrenheit, the cricket makes an additional chirp. So as it gets hotter, the cricket starts chirping more. Okay, so what we have here is a slope, and our slope is 0.25 degrees Fahrenheit per 1 chirp. Okay, so that's our slope, and that's telling us that our y-axis is temperature and our x-axis is chirps. So we could really think of this as T minus T1, temperature minus temperature 1, equals M times chirps minus chirps 1. And we're going to use our slope is 0.25. And the point that we're going to use is that the cricket chirps 40 times per minute when the temperature is 50 degrees. So T1 is 50, T minus 50 equals 0.25 times C minus 40. The chirps data point we were given was 40. Now we're going to go ahead and solve this for T. So we're going to say T minus 50 equals 0.25 C minus 1/4 of 40 is 10. And then we're going to add 50 to each side to get T equals 0.25 C plus 40. So that's our equation for part A. Now for part B, you see that we count 100 chirps in 1 minute, and we're trying to find the temperature. So we're going to use this equation that you found for part A and say that C equals 100, and then you're going to solve for T. Same idea for part C. You're going to use that equation and say that T equals 96, so substitute 96 for T, and then solve for C. All right, for this last problem, we're talking about watering plants, and we're told that this happens at a constant rate, but we're not told what that rate is. So we're given 2 points. We're given the point 5:58. After 5 seconds, the watering can contains 58 ounces, and 15 seconds later, so that's after 20 seconds, the can holds 28 ounces. So you're going to need to use these 2 points to figure out what the slope is. And then once you figure out the slope, you're going to use either one of those 2 points to write an equation in point-slope form. And then you're going to simplify that equation into slope-intercept form by solving for y. Then we need to figure out how much water was in the can when you started watering the plants. So you're going to say, well, when X equals 0, what was Y? When the number of seconds was 0, how much water was in the can? And when is the watering can empty? That's going to be when Y equals 0. You're going to figure out what's X.